Whoa, that's really weird. Okay. Hi, folks. Mr. Long here. I'm not sure why that is so grainy. Um, uh, this is a hat that that not many math teachers would be wearing. It is not my hat. It's my son's hat. It's kind of let's get to the I had the hat on, the calculus hat on the other day, so I thought, okay, maybe today I'll wear this hat. Here we go. Let's talk about intervals. Okay, so here's what we're talking about. We're going to talk about intervals, and specifically what we want to talk about is notation and the naming of types of intervals. So you're familiar with open intervals that are not that don't include values. So what we need to do, we need to talk about this because you're going to read this notation about open and closed intervals, and when you read something, and even if you know how to do the math, but you don't understand some of the vocabulary, it diverts some of your energy, and I want to make sure you're totally fluent in this. So what you'll often see is it'll say an interval is continuous on a certain interval where the endpoints are included, but it's differentiable on the interval that's where the endpoints are not included. I just want to talk about that and just review a few things. So this right here, when you have circles at the ends of the interval, it means the endpoints aren't included. So we call that an open interval because the circles are open. So how do you say that? You would say something like if you look at this graph, it is continuous and it looks like it's differentiable, right? So we might say this graph here, f at x, is continuous on the open interval from a to b, and that would mean round brackets. Okay, so it means the endpoints are not included. So we call open interval means open circles, means the endpoints are not included. What does a closed interval mean? And I think they use the word closed interval because it means things are filled in. I'm not sure if that's the absolute reason, but I'm thinking so. So in this case, this interval from x equals a to x equals b is what's called a closed interval because the endpoints are filled in. So it includes the endpoints. So how is this related to calculus? Well, what we often say is that functions are continuous over a closed interval, right? If they are continuous, and this function is. So you can get every single y value between a and b and including a and b. So a and b are both defined. They have y values, right? That's what it means. So when we have a function, we'll often say it's continuous over the closed interval a comma b. It could be 4 comma 7, whatever. Then when we describe differentiability, we're going to move over here to the open interval. What we say functions, generally speaking, are differentiable over an open interval from a to b. And it means you can't get the derivative at the endpoint. Okay, so again, derivatives are differentiable over an open interval. Continuity is over a closed interval, okay, because you can get the y values. So this is all about continuity, the y values, and over here, this is all about the derivative. So if we're going to look at this, what we really mean here is, so this is about y prime values. This is about y values. Okay, so y prime and y values. So let's take a look at why a derivative has to be on an open interval. So why can't you calculate a derivative at the endpoint of an interval? So let's take a look at this. Let's look at this this last one here. So see that I've got a tangent here. So what I'm going to do is I'm going to put a tangent right there at the endpoint. So if I put that tangent at the endpoint, if you notice, I can definitely have it. I have local linearity to the left of that point, to the left and below. But if you notice to the right, the function doesn't exist, right? So to have local linearity, I have to be able to extend the curve. The curve has to extend to the right of the point and to the left of the point. So here, my tangent, my tangent is actually only to the left. So there's my tangent. My tangent, I don't have the tangent extending to the right. So since I can't have a tangent drawn on the left and right side of that endpoint, it's not differentiable. Hence, why we say a function is differentiable only on an open interval. Okay? So when you read things and it's going to say something is differentiable on the open interval and it is continuous on the closed interval, it might say that it's once differentiable or twice differentiable. If it's twice differentiable, that just means you can get the slope function and the concavity function. If it's once differentiable, that means you can only get the slope function, right, over all those x values. Hopefully that helps and you understand this notation and ideas on open and closed intervals. You'll definitely need it as the calculus becomes more complex.